There are specific qualities to the eukaryotic chassis that enable them to self-assemble into multicellular systems in ways not observed in prokaryotes. Sure, some bacteria will produce biofilms, fruiting bodies, and spores, but such processes do not result in the morphological control accessible with eukaryotes. First is the G0 state. There are distinct phases to a eukaryote's replication cycle, and you're probably already familiar with G1, S, G2, and M states. In the G0 state, the cell enters a resting phase where they remain physiologically active, but the cells are not replicating their DNA or dividing. Non-differentiated cells and some other cells like B cells are replication competent and cycle through G1, S, G2, and M states. However, most differentiated cells are permanently locked in the G0 state. They can do translation and transcription and remain fully active biochemically, they just don't divide. No comparable state exists in prokaryotes, but the closest thing is stringent response. Here, bacteria slow all the central dogma processes. It's very challenging to have a physiologically active prokaryote that is not actively undergoing replication. The organelles of a eukaryote enable them to spatially localize specific processes that might interfere with other processes. For example, processes like respiration that occur in the inner membrane in prokaryotes are localized to specialized mitochondria in a eukaryote. This frees up the cellular membrane from obligations in central processes by diversion of those processes to specialized organelles. This allows the cell to use its cell membrane for other purposes. There is also collaboration between cells. Sealed junctions between two cells called gap junctions allow the free exchange of metabolites between two cells. Additional surface-presented features such as adherins, tight junctions, and integrins enable intimate interactions between cells that stabilize multicellular structure. Finally, they have a cytoskeleton composed of protein polymers. Like the struts supporting the roof of a circus tent, actin and microtubules maintain and determine cell shape from inside eukaryotic cells. This allows the cells to dynamically change their shapes. It also enables specialized locomotion mechanisms using lamellipodia and filopodia.